What's up, guys? Today we're going to be continuing with climate change and looking specifically at mitigation strategies. So, learning objectives. Mitigation is our main idea for today, but also focusing in on renewable energy and taking a look at the types of renewable energy that we're using. So, what is mitigation? This refers to the actions and strategies aimed at reducing or preventing the emission of greenhouse gases into the atmosphere. So, we do see some of the differences between mitigation and adaptation. The primary goal for mitigation is to reduce the extent of global warming and then reducing the impacts on our climate system. So, in other words, the critical component to understand for this is that it aims to address the underlying causes of global warming. So, in terms of how that's a little bit different from adaptation. So again, mitigation is about the root causes and addressing those, whereas adaptation is more so about coping with the existing and also anticipated impacts of climate change. So the focus of this is to reduce vulnerability and to enhance resilience, not so much to addressing the root, which is mitigation. So these are a variety of ways that mitigation has been used. We see a wide range here. Today, we're really just going to focus on energy, but keep in mind that carbon regulation, nature-based solutions, so like agroforestry and reforestation, waste reduction, carbon capture. This is kind of going hand in hand with technological innovation, but there's so many different types of technologies that are being developed right now. Sustainable urban development, awareness and education, corporate sustainability, and global collaboration, especially in the form of like international treaties and politics. So just be aware that there's a lot of different ways to approach mitigation. So our focus for today is going to be renewable energy. We have solar, wind, hydroelectric, and geothermal. So first for solar energy, it's exactly what it sounds like. I feel like this one y'all are probably pretty familiar with, harnessing the sun's radiation using photovoltaic panels, right? These right here. Sometimes also solar thermal systems that has to do with the direct warming from the radiation from the sun, but our focus is going to be mostly on photovoltaic. One of the most abundant and widely accessible sources of renewable energy. Basically, anywhere the sun is shining can use this. It can also be used for electricity generation, water heating, and then space heating and cooling, or heating and like AC. So this is just a little diagram of what this looks like. So basically these photovoltaic cells convert sunlight into electricity. This is clean, sustainable, and absolutely reduces greenhouse gas emissions. It's versatile because you can install these on residences, so you can have this on your home. But we can also have large-scale solar farms where you just have like vast expanses of land that have these photovoltaic panels harvesting that solar energy. And sunlight varies by location and weather conditions, so keep in mind this is not maybe 100% reliable. Wind energy is the next one. So this is our lovely little graphic you guys can fill in on your papers. So this is generated, wind energy is generated by kinetic energy. So as the air is moving, it pushes these wind turbines, causing them to spin. These are huge, large blades on tall towers that rotate in the wind. From a distance, they don't seem that big, but up close, these are huge blades. This is a rapidly growing source of renewable electricity, becoming more and more popular. So we have onshore and offshore. So this is onshore as in like it's on land, offshore as in this is in the water. This is also not 100% perfect in that wind can vary. Wind speed, wind consistency can vary. Some places are more windy than others. So this maybe is not the best solution for all areas. The good thing is that during operation, there's no direct greenhouse gas emissions. So that means maybe there's some in producing the materials for these wind turbines, but as they're working, no greenhouse gas emissions. This can be large scale projects as well. Often you see like huge expanses of areas that have wind turbines, but you can also have smaller projects of these as well. It is very cost competitive with fossil fuels in most places. Then we have hydroelectric energy. This is a photo actually from Switzerland, using that glacial melt to help produce that hydroelectric energy. So this is generated by the movement of water, rivers, or dams. This is one of the oldest and most established forms of renewable energy. So this has been around a long time. So the way that this works is that the water flows through turbines down here. So here we have a reservoir, the intake down here, and then it turns this turbine, which then creates the generator, turns the generator in this powerhouse, and then creates electricity, and then flows out through like the rest of the river or whatever area it might be. So dams are typically used for creating a reservoir. So this would be the dam, and it helps to control that electricity generation. So hydroelectric power is very reliable and scalable. However, at the moment, because of climate change, there are some concerns about this longer term reliability. For instance, here in Switzerland, where most of these run through glacial ice melt, which we're having less and less of. The environmental impacts, it can like alter ecosystems, fish migration. So there are some environmental impacts with this. And then finally, geothermal energy. So this utilizes heat from the Earth's core to make electricity and provide direct heating. This is the Earth's natural heat, which is pretty cool. Sometimes this is accessed through geothermal reservoirs. So we'll look at a diagram here in just a moment. This is consistent and reliable. So here we have the little diagram. So typically these plants will tap into hot water underneath the earth, or steam reservoirs beneath the Earth's surface, and that heats up this water. Then we see the steam travel through this system, which then turns the turbine and then goes into the generator here, which creates the electricity. So then once that water, that hot steam goes through, then it goes through a cooling tower and then down into the injection well. So you kind of see this circular motion here. Small environmental footprint, low emissions, so that's great. And these are usually most effective around tectonic plates because that's where we see more geothermal energy. So real quick, you can see this exhaust here. That's the cooling tower. So advantages and challenges of renewable energy. These are great alternatives, but maybe not totally perfect. So here are some advantages: environmental benefits, sustainability, economic benefits, cost competitiveness, technological innovation as well. So we see a lot of benefits. This is addressing quite a few of the concerns that we have or causes that surround climate change. However, there are challenges, right? Intermittency and variability, like I mentioned, like with the sunlight or the wind, storage and grid integration, a way to store the excess energy, and then also having to update the current power system grids is a challenge. Resource availability and location, that might not be fully accessible in certain areas, and transmission. Maybe there's a great area to put a dam, but then you would really need to figure out how to get it to areas of population. The initial cost and financing is a concern. It's a high initial investment, so this is more of like a longer term investment where you're spending a lot of money up front, but then it ends up being worth it in the long term. Land and environmental impact, there is some of this concern as well. Using some of this land for renewable energy takes away opportunity for maybe agriculture or other things that are important as well. Energy transition challenges, so policy and regulation is a big one. Like, how do we regulate these things? What kind of policies should we implement to make sure that these are done well? And that's it for mitigation. And next will be adaptation.